F-35 can be detected without radar. Here's how. Most people think stealth aircraft like the F-35 are invisible to radar, but that is not true. In fact, there are multiple ways to detect a stealth aircraft even when radar fails. And one of them does not even use radio waves at all. So the real question is not, can we see the F-35? The real question is, how is it being seen and from what distance? Before we continue, if you are interested in real explanations of modern aviation, radar physics, and stealth technology, subscribe to VectorTechExplained. Here, we break down complex systems into simple physics, no hype, just engineering. Now let's get into it. The idea that stealth aircraft are invisible comes from movies, simulations, and simplified explanations. But in real physics, nothing is invisible. Every object interacts with energy. Light, heat, radio waves, everything leaves a trace. Stealth technology does not mean cannot be detected. It means harder to detect and usually detected later. That delay is the entire game. Because in modern air combat, seconds matter. Even a few extra seconds of detection delay can completely change the outcome of a mission. That is why stealth exists, not to disappear, but to reduce the detection range. To understand detection, we need to understand how radar works. Radar works in a very simple way. A system sends out electromagnetic waves. These waves travel through space, hit an object, and reflect back. The radar system then measures the return signal. Based on that return, it calculates distance, speed, and direction. But here's the key point. The system does not need a perfect reflection. It only needs a detectable one. Now let's connect this to stealth aircraft like the F-35. The F-35 is designed to reduce something called radar cross-section. This means it does not reflect radar waves strongly back to the source. Instead, it scatters them in different directions. So the radar return signal becomes much weaker. Not zero, just weaker. And that is where the entire stealth advantage comes from. The F-35 Lightning II is one of the most advanced stealth platforms ever built. Its stealth is not one single feature, it is a combination of design choices. First, the shape. The aircraft is built with angled surfaces that reduce direct reflections back to radar sources. Second, internal weapon storage. Instead of carrying weapons externally, which would increase radar reflection, they are stored inside the aircraft. Third, special materials. The surface absorbs part of the radar energy instead of reflecting it. All of this combined reduces detection range significantly. But again, it does not eliminate detection. It only makes detection harder. And this is where modern systems start to matter. Many people imagine radar as a single rotating dish, but modern systems are far more advanced. Today's radar systems use techniques like phased array scanning, multiple frequency bands, and networked tracking systems. Instead of relying on one signal, they combine multiple weak signals over time. This means even if a stealth aircraft reduces its radar return, it can still be tracked statistically, not instantly, but gradually. Think of it like this. One drop of water is invisible, but thousands of drops still form a pattern. Modern radar systems are built to detect patterns, not just strong reflections.
This is the most important part of the video. In real operations, detection is not done by one radar. It is done by a network. Multiple sensors work together. Ground radar, airborne radar platforms, passive detection systems, and infrared tracking systems. Even if one system fails to detect a target, another system might still pick it up. This is why modern air defense is not about one technology winning. It is about combining information. And that completely changes the meaning of stealth. Now we arrive at the core idea. How can an aircraft be detected without radar? One of the most important methods is infrared detection. Every aircraft produces heat. Engines generate high temperatures. Air friction creates additional heating. Infrared systems do not send signals, they simply observe heat differences in the environment. This means that even if radar performance is reduced, heat can still reveal an aircraft's presence. However, there is an important limitation. Infrared detection depends heavily on distance, weather, and angle. So again, it is not perfect, but it adds another layer of detection. This is why modern systems use multiple detection methods at the same time. So, let's summarize everything clearly. The F-35 is not invisible. No aircraft is. Stealth means reduced detection range, reduced tracking accuracy, and delayed identification. Modern systems mean multiple detection methods, networked tracking, and statistical detection over time. So the real battlefield is not visible or invisible. It is how long can you stay undetected. That is the real competition, not magic, physics. So the next time you hear that the F-35 is invisible, remember this. Nothing is invisible in physics. Everything can be detected. The only difference is how fast and how far away. That is what defines modern stealth warfare. If you want more deep breakdowns like this, where we explain real aviation technology, radar systems, and stealth physics in a simple way, subscribe to VectorTechExplained. And in the next video, we will break down how modern systems track stealth aircraft step by step in real-time scenarios. See you in the next one.